Hello everyone. Today we'll study chapter 1 real numbers in this fundamental theorem of arithmetic. Fundamental theorem of arithmetic. We'll study this. Okay. What is fundamental theorem of arithmetic? So it is a very important theorem to find out LCM and HCF. So this fundamental theorem of arithmetic, it is also called as the unique factorization theorem or unique prime factorization theorem. Okay. Okay. So this is also called as unique factorization theorem or unique prime factorization theorem. Why it is called so? Let us take it's a statement. What is the statement of fundamental theorem of arithmetic? This is the statement. This statement is very important. Sometimes they will ask in the exam that state fundamental theorem of arithmetic. So, what is the statement? Every composite number, what do you mean by composite number? We are discussed in earlier slides, that is videos. Composite number is one which has more than two factors. For example, 4, it is the very simple example of composite numbers. That is, what are the factors of 4? It is divisible by 1, it is divisible by 2, and it is divisible by 4, that number itself. So, these are factors of 4. How many factors are there for 4? There are 3 factors. So, such number is called as composite number. 4 is the smallest composite number. Okay. So, now let us take the definition. What is the definition of fundamental theorem of arithmetic? So, every composite number can be expressed as a product of primes. A product of primes. First, let us complete this statement. Every composite number. I'll take one composite number 20. Okay. Can be expressed as product of primes. So, I'll take factors of 20. What are factors of 20? 2 into 2 into 5. Okay. 2 2s are 4, 4 5s are 20. These are prime factors. Prime numbers means the number which is divisible by 1 and that number itself are called as prime numbers. So these 3 are prime numbers. First sentence is every composite number can be expressed as a product of primes. Okay. So this composite number is expressed as product of primes. So every composite number can be expressed like this. Then, and this factorization is unique. So whatever factors are there for this 20, they are unique. Okay. So here you can write 20 is equal to 5 into 2 into 2 also we can write. Okay. Then it is unique. It is unique. Apart from the order in which the prime factors occur. What is order? Here order means I have written here 2 into 2 into 5. Here 5 into 2 into 2. But numbers are same. In both numbers are same. But only difference is the order of the numbers. Here 5 is the last factor and here I have taken it first. But numbers in both the factors are same. So the fundamental theorem of arithmetic states every composite number can be expressed as prime factorization or can be expressed as product of the prime numbers, but they are unique and order may be different. Order may be different. This is a fundamental theorem of arithmetic. Then here one example is given that we have taken now, that is by taking 20. Okay, so this is fundamental theorem of arithmetic and it's a statement. Now next, what is LCM and HCF? You know this. LCM is least common multiple. HCF is highest common factor. Okay, so here LCM, product of greatest power of each prime factor, and HCF, smallest power of each common prime factor. LCM means we take, if you are considering LCM of two numbers, then we factorize that number, and in those factorization we take greatest power of each prime factor, and here we take the smallest power which is common in both the factors. We'll solve the examples, then we'll easily get to know what is LCM and HCF. Next, there is one important relation between LCM, HCF and the two numbers. What is that? This is very much applied in finding LCM and HCF. What is that? HCF of A and B, that is A, B are two composite numbers. HCF of AB into LCM of AB is equal to product of two composite numbers. I repeat, A and B are two given composite numbers. If you find out HCF and LCM of those numbers, then you will have this relation. What is that relation? HCF into LCM is equal to A into B. On this one, with this, three unknowns, means if you know A and B and LCM, you can find out HCF. Okay, if you know A and B and HCF, you can find out LCM. This is the relation very much applied in finding HCF and LCM. Now let us take some examples on this. First example, find LCM and HCF of 6 and 20. 6 and 20. So how to find out its LCM and HCF? Solution. Okay, what we have to do, always first find out factors of the given numbers. Factors of 6. What are factors of 6? 2 into 3. Then find out factors of 20. Factors of 20. What are factors of 20? Now only we have find out 2 into 2 into 5. Then LCM. What is LCM? It is the highest power of the terms. Here 2 into 3, and this one I'll write 2 square, means 2 raised to 2 into 5. LCM. Here you have to take highest power of the terms. You have to consider. Here 2 raised to 1 is there. Here 2 raised to 2. Which one is highest? 2 raised to 2 is highest. So write 2 raised to 2 into 3 raised to 1. Here 3 is not there, means 3 raised to 0 we can write. 3 raised to 0 is 1. You have to assume like that. So 3 raised to 1 is greater. You write 3 raised to 1. Next, 5 is there. Here 5 is not there. 5 raised to 1. Here we can assume again 5 raised to 0. Which one is greater? 5 raised to 1 is greater. Into 5 raised to 1. This product gives LCM of 6 and 20. So LCM of, we write like this, 620 is equal to 2 2s are 4. Here I'll write 4, 3 into 5. It is 4 3s are 12. 12 into 5, it is 60. So LCM is 60. Next, what is HCF? HCF, highest common factor, or else HCF of 6 and 20 is the numbers whose power is the smallest. That we consider. Here I'll erase this. Okay. Just observe. Lowest power or common factors we take. Here 2 is there. Here 2 square is there. Common is only 2. That you have to write here. Here 3. Here 3 is not there. So you cannot take. Here 5 is there here, but 5 is not there. Only common, which are common in both, you have to consider those. So here only 2 is the HCF. Is it clear? Then let us check the relation, that is LCM into HCF is equal to A into B. That is LCM into HCF is equal to A into B. This is the relation we know. LCM is 60, HCF is 2. Just we are checking this relation. Actually here problem is completed. A is 6, B is 20. These are given numbers. 120 is equal to 120. Okay. So your answers are correct. In this way you can check your answers. Next, let us take next example. Find the HCF of 96 and 404 by prime factorization method. Hence find their LCM. Solution. Right? We have to find out HCF of these two numbers. So first factors. Factors of 96 is equal to 2 into 4 is 8. Start with the smallest number. 2 into, again take its factors. 2 into 2 2s are 2 4s are. Simple division I am taking. 2 into 2 into, again I'll take 2 here. 2 12s are 24. This one 2 into 2 into 2 as it is. Again this one I can write it as 2 into 6. One more step we'll take. 2 into 2 into 2 into 2 into, again factors of this, 2 into 3. So factors of 96, 2 raised to 5 into 3. Right? Now let us, here we'll take factors of 404. Factors of 404 is equal to, first I'll take 2. 2 into 2 2s are 0, 2 2s are, again 2 into, this is divisible by 2. 2 you take 101. So 2 raised to 2 into 101. Right? Now we found factors. Then we'll find out HCF. HCF of 96 404 is equal to highest common factor, which is common in both the factors. That is, just see here, 2 raised to 5 is there. Is 2 raised to 5 here? No. But 2 square is there. 2 square is common in both. You have to consider smallest power. 2 square. Here 3 is there. Here 3 is not there. 101, here it is not there. So its HCF is 2 square. That is, HCF is 4. Now LCM we can find out directly, but here we'll use that relation. That is HCF into LCM is equal to, what is the relation? A into B. Here, A means 96 and B is 404. I'll take HCF is 4 into LCM is equal to A is 96, B is 404. Then LCM is equal to, I'll transfer this 4 here. It is 96 into 404 divided by 4. Again it is 96 into 4 ones are 401. 101. So answer is 96 ones are 96. 96 ones are 96. 9696. We can check this by multiplying 96 and 404. That answer should be LCM into HCF. Okay. In this way, we can solve the examples. Let us consider one more example. Find HCF and LCM of 6, 72 and 120. Here difference is 3 numbers are given. Let us find out by using the same method, and that relation, that is HCF into LCM is equal to A into B, is applied to when there are only 2 numbers. It is not applied for 3 numbers. Remember that. So factors of 6 is equal to 2 into 3. Factors of 72 is equal to, you can pause the video and solve on your own, then compare your answers. 2 into 2, 3s are 6, 2 6 are 12. Again take factors. 2 into, what are the factors of this? 2 1s are 2 8s are is equal to 2 into 2 into, what are the factors of this? 2 into 9. While taking factors, you have to be very careful. Into 9 can be written as 3 into 3. So these are all prime factors. Then it is 2q into 3 square. Right? Similarly, we'll find out factors of 120 is equal to 2 into 2, 6 are 12, 0. Again take factors. What are factors of this? 2 into 30 is equal to 2 into 2. Factors of 15. 2 into factors of 30. 15. Again 2 into 2 into 2. Factors of 15 are 3 into 5. So all are prime now. Stop here and we'll write in powers. It is 2q into 3 into 5. Now we'll write down HCF and LCM. HCF of 6, 72, 120. HCF means highest common factor. Here 2 is there. Here also 2 is there. Here also 2 is there. Okay. So 2 is common. Into. You cannot take 2 cube here because here 2 cube is not there. You cannot take that. Which one is common in all 3? That you have to consider. Here 3 is there. Here also we have 3 and here also we have 3. So 2 into 3 is equal to 6. Next, LCM is equal to 6. LCM of 6, 72, 120. Here highest powers we consider. Here 2 raised to 1, 2 raised to 3, 2 raised to 3. So 2 raised to 3 is highest. 2 raised to 3 into. Here 3 raised to 1, 3 raised to 2, 3 raised to 1. So 3 raised to 2. Next 5 is there. Take this 5. Multiply. 2 cube is 8 into 9 into 5. How much it is? 9 5s are 9 8s are 72. 72 into 5. 10. 360 is equal to 360. So HCF is 6. LCM is 360. In this way, we have to solve the problems. So this is about fundamental theorem of arithmetic and problems based on that. Thank you.